Here we're going to look at the topic solving for a variable in terms of other variables in a linear equation with fractions. So I'm going to give you two examples where I'll kind of show you step by step how you can go about doing this. So example one, let's say I'm given the equation A equals B minus C plus D all over 6. Okay, so, and let's say they want you to solve for D. What I like to do is, of course, you got to write the problem down, and then I like to circle the variable that I'm trying to isolate or get by itself. Now, if you have a fraction, what I'm going to try to do is clear the fractions. Just like any time in any equation that I have fractions, I like to try to get rid of them so that I don't have to deal with the fractions for the rest of the problem. Now here, the only fraction I have is this one with a denominator of 6, and if I had to write A as a fraction, I can write it over 1. So the LCD of this entire equation is 6. So all I'm going to do is multiply all terms in the entire equation by 6, just like we did if you were solving a linear equation that happened to have fractions. So I'm going to multiply this side by 6, or this term by 6, and I'm going to also multiply this entire fraction by 6. What that's going to do, at least on this side where the fraction is 6 divided by 6 cancel out, and I'm going to be left with just B minus C plus D, which is kind of nice. I have no more fraction. Over here, I can't cancel out any denominators, but the good news is the denominator is only 1 anyway, so there's nothing to cancel out. And I just have to multiply 6 times A to get 6A. So now remember, don't lose sight. We're trying to get D by itself. So I really just want to move these variables to the other side, to the left side of the equation. Now since D is not being multiplied by these variables, I'm just like either adding or subtracting them, I'm going to simply add or subtract them over to the other side. So since B is just positive here, I'm going to subtract B. I'm going to do a minus B on both sides. That'll give me a 6A minus B over here. I can't subtract them. They're not like terms. B minus B do cancel, and now I have equals negative C plus D. My last step is going to be to move that negative C over by adding C to both sides. So my final answer should look like this if I write it in alphabetical order. And I don't think Alex will care if it's in alphabetical order or not, but you should have a positive 6A, a minus B, a plus C equals, these canceled out, equals D. So now D is solved and isolated. So there's one example. I'm going to show you one more example just because it might be worth seeing two at work here. Let's call this example 2. And let's say I have capital M equals 3x minus y over 7. This is similar, maybe even easier. Again, I have a fraction and I want to get rid of the fraction, so I'm going to multiply both sides. Oops, that's supposed to be just m over 1. I was trying to make that into a fraction. I'm going to try to multiply both sides by that LCD, which is 7. I know that by doing that, if I multiply this fraction by 7 and this side by 7, these 7's will cancel, leaving 3x minus y and no more fraction, right? Over here, I'm just going to have 7m. And just like we did last time, I'm going to maybe be clear here. I'm sorry if I didn't say this. Let's solve for y. Kind of important to know what you're trying to do for the problem. So I should have started by saying let's solve for y. Either way, if we were solving for x or y, we would still want to multiply by 7 to get rid of the fraction. So now I'm trying to get y by itself. I'm going to subtract the 3x over. So now I have a 7m minus a 3x equals negative y. Now to get rid of the negative, I'm just going to divide everything by negative 1, which in effect switches the sign. So it's going to be negative 7m's plus 3x's equals y. And that will be my final answer solved for y. Hopefully this helps you. Good luck.